This is Mrs. O'Neill for AP Chemistry, Chapter 24, Section 3, Alkenes, Alkynes, and Aromatic Hydrocarbons. In this section, you're going to explore hydrocarbons that contain double bonds, which we're going to call an alkene, and a triple bond, which we're going to call an alkyne. So again, pause the video, fill in the blanks, read as you write, and then play to hear my words. So the first thing to think about is there's no methene. Why is there no methene? Well, there's no way you're going to have a double bond between a carbon and a hydrogen. The double bonds and the triple bonds really occur between two carbon atoms. So in your notes you have a chart. Fill in the blanks of the chart. Now, hopefully you're understanding the different ways you're going to see these organic compounds, the names of these organic compounds, and the common names between these organic compounds. A lot of your organic professors or your organic chemists really don't give it its proper name. In this case, this is called ethene, but a lot of your chemists, especially organic, will call it ethylene. Why? I am not sure. So here are some common alkenes. So if we look at the first one here, okay, again, your common name is ethylene, but for our purposes, we're going to call it ethene. And in this case, again, our double bond is only between two C's. So we can number it from left to right or right to left. It doesn't matter in this case. However, the second example here, propylene, again, common name, you're going to name it propene. That's why that's the word you're writing down in your notes. Well, now let's look at this. This would be carbon 1, 2, 3, or are we numbering it carbon 1, 2, 3? Well, this double bond now really is a functional group. So like all other functional groups, we're going to consider that to be important, even more important than, let's say, a methyl or an ethyl group. So because it's that important, we actually have to number this as our carbon 1. So this would be carbon 1, carbon 2, and carbon 3. So that's the way our chain would go, because priority is put on the double bond. And so because it's our first carbon, we don't even need a 1 here. Some professors might want you to put a 1 propene just to make sure you're understanding that that double bond comes from that first C, but really it's not necessary. It's more like common sense there. Okay, now let's look at this guy. Is the longest chain 1, 2, 3, 4 carbons, or is the longest chain 1, 2, 3? Hopefully you figured out that it's 3, prop, right? 3. That fourth one is now going to be a functional group. So again, the common name isobutylene is really 2-methylpropene. Okay, so now what's going on here? So number 1, prop means that there are 3 carbons. Well, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so no matter what, I get 3 carbons as my longest chain. However, how am I going to number it? Now notice, again, prop is 3. Ene tells me that there's a double bond. That takes precedence. Just like we did here, we're going to make sure that that double bond is on our lowest carbon. So we have to start here. So this is going to be carbon 1 and 2. Now, it really doesn't matter. We can go up or we can go down. It really doesn't matter. But I want to show you if that's our longest chain, that means we have a functional group. It's 1 carbon, so that's going to be methyl. So carbon number 1, carbon number 2, that's where the 2-methyl comes from. And since there's 3 carbons in our longest chain, that's where the propene comes from. And we will do more examples in class. Again, these are just simple ones. So how about that fourth one? Again, I'm giving you the answers, but let's look at the name here. So again, ene tells us that we have double bonds. Now, bute tells us that we have 4 carbons. Now, am I going to number it 1, 2, 3, 4 or 1, 2, 3, 4? Now, this is a little tricky because not only do we have 2 double bonds, so the di and the 1, 3 comes from that double bond, but now we also have a methyl group. We got this guy sticking up. Okay, so 1, 2, that would be on the 2nd carbon. 1, 2, 3, it would be on the 3rd carbon. So we are going to number from left to right. 1, 2, 3, 4. Excuse me, that's the bute. There's 2 double bonds, so again the double bond should be on our lowest carbon number, right? So it could have been this way or this way, but because we have this methyl group, we also want to make sure that that methyl group is also on our lowest numbered carbon in our longest chain. So that's where we get 2-methyl, 1, 2, 3, butadiene it's called. Now sometimes I see it 1,3-dibutene or butene, but most of the time the di goes right before the ene to signify that I have two double bonds. So I think in your packet you just have to write these words, but if you did want to write down the structures next to it, that's up to you as well. There's also called geometric isomers. Now you know that an isomer, or hopefully by now you know that an isomer is two compounds that have exactly the same formula. Now remember, formulas don't tell us much. It's the structures of those compounds that will tell us how they're going to interact or react with other compounds. So what's going on here? Well, why do we need a cis and a trans? Why do we need two different ones? Well, again, here's our double bond. And if we haven't done so already, you're going to be working with model kits for labs. When you deal with those model kits, when you have single bonds, the bonds can rotate, or those atoms can rotate around each other. However, when you have a double bond, the double bond kind of stays really, really strong and stable, and you can't twist and turn. So this carbon and these carbons, you can't twist and turn them around. They're not going to be able to rotate on an axis, just like, but this carbon and this carbon will be able to, right? Can be able to spin this around, no problem. But because of that double bond, you cannot twist and turn. You cannot rotate that carbon around. So because of that, we have two methyl groups here. So these two methyl groups are on the same side of that double bond. That's why it's called cis, same side. Where here the methyl groups are on opposite sides of that double bond, so they're called trans. Trans is for opposite. Okay, so cis and trans. Again, this is why structures are really, really, really important as far as a compound. Because the formula doesn't tell us much. It is the structure, how those atoms are put together, that really tells us how they're going to interact with other things. So again, just a quick reminder that you are always numbering your double bond as a functional group, so it should always start on the lowest number carbon atom in your chain. So here we have 6 carbons in our lowest in our longest chain. We have a double bond starting at number 1 carbon. So it's not necessary here to have 1 hexene, but again, it's just there for a stronger emphasis. So again, here carbon 1, carbon 2, the double bond starts on our carbon 2, so that's where the 2 comes from. Hex, of course, that there's 6 carbons in our longest chain. Of course, that ene tells us that that's their double bond. Now, in this case, we could have numbered 1, 2, 3, so it's on our 3rd out of 6, or we could actually number it the other way. Carbon 1, 2, 3. Could have also numbered it the other way and still would have gotten 3 hexene. So alkynes are basically the same thing, except now we're dealing with a triple bond instead of a double bond. But notice, if we're numbering left to right, our triple bond would have been on carbon 1, 2, 3, 4, 5. But if we're numbering from right to left, it's on carbon 1, 2, 3. So again, that's going to take precedence over that methyl group. So again, in your notes, please write this down and notice the common name versus the name that you should give. Aromatics are usually benzene. So in your notes you have a chart that you're going to draw a few different ways benzene is shown. So this is the most common way. You got your 1, 2, 3, 4, 5, 6 carbons, but notice if you can see it, this is a single double, single double bond. So those are a rotating or like a pattern of single and double bonds. And because of that, sometimes you will see this way or that way. It's the same thing, but different professors and different chemists just show it in a different way. Now, benzene also has what's called residence structure. Now, to you, these two structures might look exactly alike, but they're slightly different in the fact of this is carbon number 1, 2, 3, 4. This is carbon number 1, 2, 3, 4. If you notice, the pattern is slightly different. Here we have double, single, double, but here we have single, double, single. So this residence structure, and we'll talk more about it in detail later on, but residence just means that it's the same structure, but I can draw it multiple ways because that double bond can be on different numbered carbons. Okay, so if that makes any sense. So carbon 1 here has a double bond, but carbon 1 here has a single bond. So that's why it's called residence structure. Now, Why this occurs, I'm not sure, but instead of a functional group benzene called phenyl, they call it, or benzyl or whatever, I don't know, they call it phenyl. So anytime you have a functional group as a benzene ring, again, this R means that this would be a carbon, right, or a chain of carbons. So this would be our functional group of phenyl. So because benzene has these weird, again, you have this benzene ring, now you have functional groups that can come off of each of the carbons, right? So instead of H's, let's say that this is a chlorine and a chlorine. Well, if these two chlorines were right next to each other, that's going to be called ortho. If the chlorines are 2 away from each other, it's called meta, and if they're 3 away from each other, it's called para. I believe in your notes again, I have written ortho, meta, para. You just need to make sure that you're drawing that, okay, ortho means that they're right next to each other, meta is 2 away from each other, and para is 3. Now, it doesn't have to be the same element either. It doesn't have to be 2 chlorines or 2 bromines. This could be a list of carbon chains, and then this could be, I don't know, bromine. Okay, so it really doesn't matter. It's just saying that if you have 2 groups coming off of a benzene ring and they're right next to each other, that's ortho, meta, and then para would be that way. So again, here are some examples of what you might see in these squiggly lines. Again, they're just talking about a carbon chain or a group, or, you know, whatever, bromine, chlorine, like I said. The other thing I wanted to bring to your attention, though, if it has an OH group, now it turns into an alcohol. Again, one of those functional groups of an alcohol. So now instead of phenyl, it's actually phenol. So again, maybe some of these things you've heard of in the past, or you might hear in the future, as far as, and so now you have an idea of what that means. And again, ortho, meta, and para examples as well. Okay, see you in class. Hopefully some of that makes sense. And again, I am always willing to answer questions.